Now, I don't want to freak you out, but something bizarre has erupted in the depths of space. It was an explosion brighter than billions of suns. But the real mystery is that it doesn't match anything astronomers have ever seen. Usually, cosmic events like this follow familiar patterns, but not this one. It's a cosmic anomaly. This strange cosmic explosion has left astronomers totally baffled. It could be a super rare event where everything lines up just right, or it could be something completely new, never seen before. This event was first detected by an X-ray space telescope called the Einstein probe on April 8, 2024. It first appeared to be a regular gamma-ray burst. Those typically give off incredibly bright X-rays. But could the answer really be so simple? Something didn't add up. Now, gamma-ray bursts are the most powerful explosions in the universe, and they can happen in unusual ways. Long-duration gamma-ray bursts are caused by the demise of massive stars that spin incredibly quickly. When these stars run out of fuel, their cores collapse under gravity, forming an extremely dense object, like a black hole. At the same time, the outer layers of the star are blown away in a massive explosion called a supernova. Gamma-ray bursts are followed by jets. Those are twin beams of material shooting out from opposite sides of the collapsing object. They're super fast, moving at nearly the speed of light. These jets appear brighter if they're pointed directly at us. It's like how a flashlight beam is brightest when it's aimed straight at you rather than at an angle. Now back to our unusual cosmic explosion. Remember me telling you something wasn't adding up? Hey, it was just 45 seconds ago. Well, the problem was that when multiple telescopes observed this event in different wavelengths – ultraviolet, optical, near-infrared, radio, X-rays, gamma rays, you name it – it didn't match any known type of event. The most likely explanation, according to current research, is that this explosion is the result of a white dwarf star being torn apart by a medium-sized black hole. And still, it's not so simple. Now, black holes are areas in space where gravity is so strong that nothing, not even light, can escape. That's why they're called black holes. It's believed that stars with at least 3 times the mass of our Sun can collapse under their own gravity once they run out of their stellar fuel. When a star has so much mass packed into such a small space, its gravity becomes so powerful that it forces everything, including atoms, to squish together. This intense density leads to the formation of a black hole. So, when a white dwarf star is torn apart by a medium-sized black hole, it results in a high-speed jet of material that can be aimed directly at Earth. So, could this space disaster be the reason behind our mysterious event? Unfortunately, even though it ticks some boxes for several types of phenomena, including the one involving a white dwarf, it still doesn't fit all the criteria for any of them. The event's short duration and high luminosity are hard to explain using any scenarios we can produce. So, does it mean we have come across something completely new? The universe is full of energetic flashes caused by outbursts from stars and black holes, supernova explosions, stars being eaten by black holes, and other cosmic events. Astronomers usually figure out what these events are by analyzing their duration, frequency, source, and the specific combination of wavelengths they emit. Here, I just have to say a few words about the instrument that discovered the space anomaly. The Einstein probe is an X-ray space telescope project led by the Chinese Academy of Science in collaboration with the European Space Agency and the Max Planck Institute for Extraterrestrial Physics. That's a mouthful. This project is all about studying high-energy space events over time. Its main goal is to find inactive black holes and figure out how matter falls into them by spotting X-ray flares produced by these sudden space events. The Einstein probe also hopes to catch the electromagnetic signals from events that cause gravitational waves, like when neutron stars merge. It also keeps an eye on the whole sky to spot all kinds of space explosions and track already known changing X-ray sources. After the Einstein probe detected that ultra-bright space flash, the event was also observed by a few other ground-based and space telescopes, including the Nuclear Spectroscopic Telescope Array, SWIFT, Gemini, Keck, Dark Energy Camera, Very Large Array, Australia Telescope Compact Array, and Neutron Star Interior Composition Explorer. That's a bigger mouthful. Using all this data, astronomers pieced together the event's characteristics, but it didn't make the case any clearer. Quite the opposite. It just deepened the mystery. This event flared up in soft X-rays for the first 10 seconds, then plateaued at a steady glow for about 4 days before fading quickly within another day. This is much longer than typical gamma-ray bursts, which usually last from a few milliseconds to several hours. But it was still not long enough to fit into other known categories. The event's brightness in X-rays was also unusual. It was too bright for some types of phenomenon, but not bright enough for others. The most puzzling part is that the Very Large Array didn't detect any radio emission from the source when it was observed 11 days, 158 days, and 258 days after the initial flare. And normally, when something this bright in X-rays lasts for this long, it's usually associated with a luminous radio counterpart. But in this case, no radio signals were detected, which is very strange and adds to the mystery. Astronomers didn't give up and considered several other possibilities, like fast blue optical transients. Those are a new class of explosions that release huge amounts of energy and blast matter into space at incredibly high speeds. These bursts are so powerful that one F-bot can be at least 10 times more powerful than a regular supernova. Fast blue optical transients do look like supernova explosions, but they are much faster. They flare up and fade away much more quickly than regular supernova. They're also much hotter, which makes the light seem bluer compared to other supernova. Since these explosions happen so quickly, it's tough to figure out what causes them. In January 2019, astronomers narrowed it down to 2 causes: a black hole consuming a white dwarf star, or a rare kind of supernova that leads to the formation of a neutron star or a black hole. Now, another explanation for our mysterious space explosion, and astronomers think it's the most likely one, is a tidal disruption event. It happens when a black hole swallows a star, causing a flash of light. When a star gets too close to a supermassive black hole, it doesn't get off easily. No, the black hole's powerful tidal forces tear the star apart, breaking it into pieces and pulling it toward the black hole. Its remains turn into a stream of debris that falls toward the black hole's accretion disk. However, before the debris settles into the disk, it overshoots the black hole in an elliptical path, only to be pulled back in. At one point in this path, the debris collides violently with other parts of the star being pulled in, and that's when we start to see the first bursts of emissions. In some rare cases, tidal disruption events create huge jets of material that shoot out from the black hole's poles. If these jets happen to point directly at Earth, we can see the signature of the event. It often looks like an intermediate mass black hole eating a white dwarf star. However, there should still be some radio emissions coming from the jet of a tidal disruption event. The reason none have been detected yet might be that the event was likely observed too early. Previous studies suggest that it can take hundreds or even thousands of days for the jet material to slow down enough to start sending out radio signals. If future observations pick up radio emissions, it could help solve the mystery. But if there are no signals, it might mean it's a very unusual gamma-ray burst or something completely new that we haven't seen before. The Milky Way galaxy, where we live, looks like a ginormous pinwheel rotating in space. It's a spiral galaxy that appeared around 14 billion years ago. It's filled with a lot of stuff: stars, nebulae, which are clouds of dust and gas, planets, asteroids, you and me and your parents and that messy kid down the street. You get the idea. And all these fan out from the center of the galaxy in long spiraling arms. A marvelous view. The Milky Way is about 100,000 light-years across, and it takes our Sun, along with all the solar system, 250 million years to make one revolution around the center of our home galaxy. Wow, that's a big lap. Look at the sky at night and most stars you see there would be located in just one of the Milky Way's arms. Before telescopes were invented, people couldn't see stars clearly. They blurred together into a single white streak stretching across the sky. It looked like a river of milk, and that's how the name of our galaxy appeared. Now, let's get down to some recent and very exciting news. An international team of scientists have discovered something they've never seen before, hidden in the center of the Milky Way. It resembles Morse code. Is that our galaxy trying to communicate with us? In the early 1980s, astronomers discovered giant one-dimensional filaments dangling vertically near Sagittarius A star. That's our galaxy's central supermassive black hole. And recently, a new kind of such filament has been found. But they're much shorter and lie either horizontally or radially. In other words, they're spreading out like spokes on a wheel, going away from the black hole. Interestingly, even though both types of filaments do have certain similarities, researchers believe they most likely have different origins. The vertical filaments stretch through the galaxy, towering up to 150 light-years high. But the horizontal ones resemble the dashes and dots of Morse code. Scientists were beyond excited when they made this discovery, but they had to do a lot of research to make sure the structures indeed were what they looked like. They managed to confirm that the filaments were not random, but tied to the outflow of the black hole. Thanks to them, it became possible to study the spin of the black hole and the orientation of its accretion disk, a rotating disk of matter formed around the black hole under the influence of its immense gravitational force. But let's have a closer look at the filaments we've been talking about. There are around 1,000 vertical ones. They appear in pairs and clusters and are often either equally spaced or side by side like strings on a harp. As for their horizontal counterparts, they seem to be around 6 million years old. Now, both types of filaments are one-dimensional. They can be viewed with radio waves, and they seem to be tied to processes happening in the galactic center. That's it. The similarities end there. The vertical filaments are perpendicular to the galactic plane. The horizontal ones are parallel, but at the same time, they point radially toward the center of the galaxy and the black hole. The vertical filaments are magnetic. The horizontal ones seem to emit thermal radiation. The vertical filaments contain particles moving at speeds very close to the speed of light. The horizontal ones don't do it. There are way more vertical filaments, and they're much larger than those stretching horizontally, 150 light-years against 5 to 10 light-years at most. In any case, the new discovery is still filled with tons of unknown things, and astronomers are ready to start unraveling them. But the filaments aren't the only unexpected and bizarre phenomenon in the solar system. Some time ago, Australian researchers discovered a weird spinning object in the Milky Way, and it was unlike anything they'd seen before. This object released massive bursts of radio energy 3 times every hour. And even though there are other objects that switch on and off, for example pulsars, such frequent pulsation has never been observed before. Some astronomers admitted that this discovery was pretty spooky, since no known object in the sky could do it. Research teams started working on the discovery and found out that the object is likely to be 4,000 light-years away from Earth. It's also super bright and has an incredibly strong magnetic field. And still, if you do all the math, not me, you'll discover that it isn't supposed to have enough power to produce such radio waves every 20 minutes. The theories about the origin of this mysterious object vary. Some experts claim it could be an ultra-long period magnetar, whatever that is. Others think it might be a white dwarf or the remnants of a collapsed star. But it also might be something we've never heard about, an entirely new type of object. But one thing is clear, astronomers managed to observe the signal across a wide range of frequencies, which means it has a natural origin and isn't something artificial. Now, there's another mystery about the Milky Way. Hey, what can I say? It's a mysterious place. Around 15 years ago, astronomers launched the Fermi Gamma Ray Space Telescope. Gamma rays are an incredibly high-energy form of light. That's why, when you observe the sky through the gamma ray telescope rather than with your own eyes, the difference is dramatic. So when astronomers started to use the telescope, they noticed that the center of our galaxy emitted much more gamma radiation than, for example, its outskirts. To put it simply, something is growing incredibly brightly right in the middle of the Milky Way. But the most perplexing thing is that no one has been able to find a plausible explanation for this phenomenon for almost a decade. Some astronomers suggested that the central region of the Milky Way was glowing with such intensity because the dark matter was getting destroyed there. While no one has ever observed dark matter annihilation, scientists have been hypothesizing about this phenomenon for a long time. Naturally, we wouldn't be able to see dark matter itself, but the process could be producing the radiation the gamma-ray telescope has spotted. That's how it could be happening. If particles of dark matter collided, just like ordinary matter particles do in particle accelerators, they would annihilate one another, and as a result, they would burst into a shower of other particles, including the ones that make up gamma rays. But that's where the problem lies. If the mystifying glow was created by the annihilation of dark matter, then gamma-ray particles would get distributed evenly in space. Instead, they gather together in clumps. That's why, to the great disappointment of numerous supporters, the theory based on the dark matter came up short. There is an alternative explanation of why the Milky Way is glowing. The culprit might be a group of millisecond pulsars, which are neutron stars spinning incredibly fast. And when I say fast, I mean about 1,000 times per second. The theory that the glow is caused by millisecond pulsars is quite plausible. As I mentioned before, the light coming from there is clumpy rather than smooth, and it often happens when the source of light is one individual object, such as a pulsar. Several studies have concluded that, due to the nature of the light, millisecond pulsars are the best explanation for this phenomenon. However, many scientists are still not persuaded. Those stubborn folk want proof, right? Well, first of all, they state that the clumps of light may appear due to the interaction of gas between stars and cosmic rays. Besides, the pulsar theory has one more catch. Why would so many of them be clustered together in a perfect sphere around the center of the Milky Way? Probably the clusters of stars that orbit the Milky Way could have been disrupted by the galaxy's gravity. As a result, these spilled stars, including pulsars, later formed a spherical shell around the center of the Milky Way. But, in fact, the whole picture looks like something completely different from both pulsars and dark matter. It leaves scientists with more questions than answers, and all that's left to do is a lot more research and testing.
On March 24th, European skies were dominated by a glowing, insane blue spiral. The eerie sight kept growing, expanding, almost like the whole Earth was about to get sucked into a vortex. And after a couple of minutes, poof, it suddenly disappeared. Even though it looked like some kind of extraterrestrial tech, there's actually a very human explanation behind it. Photos of this strange swirl started popping up all over Europe, with people sharing them from countries like the United Kingdom, France, Norway, and Germany. But if we really want to figure out what happened, we have to look all the way over to the United States. Turns out, on that same day, SpaceX's Falcon 9 rocket was launched from Florida at around 1:50 in the afternoon local time. So while most people in the US saw clear skies after the launch, it actually caused that strange anomaly in the European skies. And that happened because Falcon 9 is a reusable rocket. So, after launching into space, it releases what is called its payload. And by that, I mean whatever it is carrying, like a satellite. After completing its mission, the rocket itself turns back toward Earth. As it does, it ejects any leftover fuel, which instantly freezes due to the high altitude, forming a spiral pattern because of the rocket's movement. Light then reflects off the frozen fuel, making it visible from Earth. Basically, that's what the blue spiral was, leftover fuel released by the rocket in space. So, should we be worried down here on the ground? I mean, is it dangerous? Well, no. It's not like it was some kind of spacecraft accident, it's just leftovers and light. And this is totally normal for the Falcon 9 rocket. Even though it went viral this time, the same phenomenon was spotted about 4 years ago. Back then, people speculated all kinds of things, like a swirling galaxy moving across the sky, or even an unidentified, unexplained flying object. But nah, it was just one of Elon Musk's space toys. Speaking of which, his space agency is also behind another eerie sighting that's becoming more common. On clear nights, many people have reported seeing a strange string of lights moving quickly in a straight line, almost like a train of stars. Those aren't drones, and they're definitely not perfectly organized shooting stars. These strange lights are actually Starlink satellites from SpaceX. You know, that project that beams high-speed internet from space using thousands of tiny satellites, basically turning the entire planet into a giant Wi-Fi zone. But wait, satellites don't have lights on them. So how is it possible that they look so bright at night? Well, basically, what we're seeing is the sun reflecting off the satellites as they travel through their lowest orbit. And they're only visible if the sky isn't too bright. What's really impressive is that you can see this same event more than once on the same day. That's because Starlink satellites travel at a staggering speed of 300 miles per minute, and they complete one full orbit of Earth every 90 minutes. So, doing the math, that means you could spot those satellites within 2 hours of a previous sighting. Without a doubt, the beginning of the year was busy for skywatchers in the United States. In February, they got to see this stunning cloudy jellyfish shape taking over the sky. What do you think it is? If you guessed another thing related to SpaceX, you're right. This is another art created by a Falcon 9 rocket. This time, it happened because the rocket was launched during the evening twilight. The light from the setting sun bounces off the rocket's smoke trail, creating this amazing effect. Now, let's move on to Italy, where another creepy event occurred. It was a stormy night, and suddenly, way up in the sky, a giant glowing red ring flashed for just a split second. Nope, it was not an extraterrestrial portal. This is something called an ELV. This happens when a powerful lightning strike sends out an electromagnetic pulse that hits the ionosphere, which is a super high up layer of our atmosphere. When this happens, nitrogen atoms up there get excited and glow red, creating a massive but super quick light show. Another red phenomenon happened in Scandinavia, but instead of a ring, it was more like a streak of light. This is known as a stable auroral red arc, or SAR. Despite the name, it's not an aurora. It's something much rarer. This phenomenon happens when the Earth's magnetic field, which acts like a big protective shield, gets disturbed. This disturbance causes some gas in the atmosphere to get super hot, thanks to a huge electrical current around the planet. What's weird is that only oxygen gets heated up during a SAR, which is why these light shows always glow that same red color. And fun fact, this event is more likely to happen after a big solar storm weakens Earth's magnetic field. It is impressive to see phenomena like this with the naked eye, but the view from outside Earth can be just as stunning. In 2022, an astronaut aboard the International Space Station spotted two bizarre blue blobs of light glimmering in our planet's atmosphere. They happened at the same time, but they weren't related at all. One of them was a massive lightning strike that hit right next to a large circular gap in the clouds. The lightning lit up the surrounding cloud walls, creating a glowing ring around the hole. Another one was caused by the moon. The way the moon was positioned made the sunlight it reflected pass through Earth's atmosphere, creating a bright blue blob with a fuzzy ring around it. And if you're wondering what that weird orange halo is, running parallel to the curvature of the Earth, I've got you. That's the edge of the atmosphere, also known as Earth's limb. And this is what it looks like when viewed from the International Space Station. In Canada, residents of central Alberta were looking up at the sky one night when they suddenly saw something strange. a bunch of vertical beams of light that seem to be coming from the ground and reaching up into the blackness of space. It sure looked like something out of a science fiction movie, but this is actually just an optical illusion. Yep, it's a visual trick caused by some specific winter conditions. This phenomenon happens when light is refracted by ice crystals. Here's what's going on. When it's freezing outside, tiny ice crystals form in the air. These crystals are super thin and flat, so each one acts like a tiny mirror that reflects light sources positioned below it. Basically, the crystals reflect the light straight up, creating those glowing vertical beams. And it can be caused by any light source, like the sun or the moon. But in most cases, the sources of these light pillars is man-made, like car headlights or streetlights. Even though the phenomenon is completely natural, it rarely happens, and only in very specific situations. First, it has to be freezing cold. On that particular day in central Alberta, for example, the temperature was around minus 30 degrees Fahrenheit. Then, the weather has to be calm, with no wind at all. If a storm breaks out, forget it. You won't be able to see the light pillars. And don't mix them up with auroras, okay? Auroras are mostly seen in high-latitude regions, like around the Arctic and Antarctic. Since they happen way up in the atmosphere, they're visible over large areas. Light pillars, on the other hand, are more localized and concentrated in a much smaller area. But hey, no matter which one you spot, if you're lucky enough to see one of these amazing sights in the sky, you're in for a show you won't forget. So, you decide to give a ball a good kick across the floor. It goes flying. But here's the cool part. For those few seconds it's soaring through the air, you're not just witnessing the usual three dimension of height, width, and depth. But there's another dimension in play. Time. Now, I know what you're thinking. How on earth can we see time? Well, we can't exactly see time itself, but we can observe its effects. And what better way to do that than by watching the ball's movements? As it travels through space, we get a glimpse of that progression of time. It's like a sneak peek into the fourth dimension. But when we dive into discussions about space-time, we often throw in an extra dimension, the fifth one. Think of it as a micro-dimension, not as obvious as the other four. You won't spot it just by kicking a ball around. In the epic movie Interstellar, there's this whole thing about these fifth dimension beings secretly helping out the main characters. These beings are from another realm or something, and they hook them up with a sweet spaceship and a super convenient wormhole for intergalactic travel. At the end of the film, they go through a black hole and end up in this crazy library of infinite knowledge. And those mysterious beings are actually McConaughey himself. Before we get too deep, let's start with the building blocks of everything in this universe. Point. Yep, that tiny little dot holds the key to it all. Let's label it as zero dimension. Dimension number 1 is just a line, a super skinny line stretching from point A to point B, like a tightrope walker defying gravity. It's like a ghostly concept that we can understand, but in reality, our world is all about things we can touch and see. Even the tiniest stuff around us has some length and width, unlike this elusive line. Dimension number 2 is a plane. When you take a line and give it some width, you got yourself a plane. It's like a flat surface that you can view head-on. Think floors, ceilings, tabletops, TV screens, and movie screens. As easy as it is to imagine a plane, it just can't quite exist in our reality. Yep, even sheets of paper have some depth to them. However, you've seen the second dimension if you've ever watched any pre-internet cartoon. Typically, all the vintage cartoons out there are two-dimensional. Now, welcome dimension number 3, which is space. It's the one we call our own. When you add a little something to a line, it magically transforms into a plane. And guess what? When you blow it up from a different angle, that plane becomes an object in our super cool world. We're all about length, width, and depth here. They're totally our jam. Time is dimension number 4. Close your eyes and imagine yourself right now, in this very moment. Now picture yourself 2 minutes ago. Or how about 2 days ago? Wait, let's take it up a notch. 2 years ago. And what about 2 centuries ago? Now here's where things get funky. Imagine all these versions of yourself from different points in time, connected along a timeline. It's like you're physically linked to each of these variations of yourself. It may sound complicated, but in reality, the jump from the 3rd dimension to the 4th dimension is just like the previous jumps we've made. Imagine you're looking at a line. If you change your perspective a bit, that line becomes a whole plane. It's like a revelation that the super skinny line you saw before was just one part of a bigger physical object, its length to be exact. Now let's take it a step further. When you shift your gaze from the plane to an everyday object or even a person, that plane becomes like a frozen snapshot of that thing. It's just one side of it, without any depth or perspective. But if you physically turn around and look at that single face, you're entering Dimension 3. If you repeat this process once again, you'll find yourself in Dimension 4. Now you're not just looking at an object from its 3 special dimensions, but you're seeing it as one face of a timeline. It's like realizing that any object we know is just one part of a whole timeline. If you could step outside of time and zip across that timeline, you'd witness all the different versions of that object, its past, present, and future. Like flipping through a crazy flipbook. It's like having all those individual frames strung together forever in both directions. And what about dimension number 5? This is where we find McConaughey in that bookcase scene. Get ready to leave the 4th dimension behind and dive into a world of endless possibilities. You see, those physical manifestations we witness are just one side of the story. They represent the realm of possibility. Now imagine a timeline as a bunch of possibilities stemming from a single moment. Let's use your birth as an example. Each moment in your life is like a face on a never-ending you from the 4th dimension's perspective. Now picture this timeline as just one face on a crazy object made up of countless other timelines. Each line represents all the different moments and faces that could have happened after your birth. It's like the 5th dimension's view of you. Back in 1905, Albert Einstein dropped some pretty cool knowledge on us with his special theory of relativity. He revealed that space and time are all tied together by the speed limit of light. So technically, our universe has 4 dimensions of space-time. But for our everyday lives, we like to keep things simple and think of the universe as having 3 dimensions of space. You know, north, south, east, west, up, down, and 1 dimension of time, which is past and future. Easy peasy. In the 1920s, a couple of genius physicists named Oscar Klein and Theodore Kaluza were like, hey, what if there's a 5th dimension of space? They got this wild idea from Einstein's theory of relativity, which showed that mass can warp space-time. So they wondered, could this extra dimension explain another force called the electromagnetic force? Turns out, it totally could. But here's the catch. The electromagnetic force is way stronger than gravity, like 1,040 times stronger. So for this extra dimension to work its magic, it had to be super tiny. We're talking smaller than an atom, like microscopic small, so small that we wouldn't even notice it. Picture a particle, like an electron, zipping through space and doing loop-de-loops around this 5th dimension, like a little hamster on a wheel. Kaluza and Klein's 5-dimensional theory got hit hard when 2 more fundamental forces were discovered in the atomic nucleus: the strong and weak nuclear forces. But many other scientists who believe in string theory brought back the idea of extra dimensions explaining forces, and it's been about half a century since then. According to this theory, the universe's fundamental building blocks are not particles, but these super tiny strings made of mass energy. These strings do their thing by vibrating in a 10-dimensional space-time, with 6 of those dimensions rolled up way smaller than an atom. String theory suggests that our universe might be like a 3-dimensional island, or a brain just floating around in this massive 10-dimensional space-time. This could explain why gravity is so ridiculously weak compared to the other 3 fundamental forces. The idea is that while the forces are stuck on the brain, gravity sneaks out into those 6 extra space dimensions, making it super diluted on the brain. In 1999, Lisa Randall and Raman Sundram had a mind-bending idea. They suggested that there could be a bigger 5th dimension, all curved in a way that we can't even see. And this extra dimension might solve one of the biggest mysteries of the cosmos: dark matter. You know, that invisible stuff that outweighs all the visible stars and galaxies by 6 times? Yeah, it might just be hiding in that mysterious extra dimension. In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way, as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant, 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them. A space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else: the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare, massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby. So what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and 1 billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: luminous fast blue optical transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted 3 crucial differences. Number 1, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number 2, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. And the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at 2 prime suspects here. It could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. And that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happened in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great. So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure. The Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot-wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution.
Portals. Non-existent, but incredibly fascinating phenomena that we see in sci-fi media all the time. We've tried to invent them and understand how they could work from ancient times. But what if portals were more than just a fantasy? What if they were real and could actually be created and controlled? What if we could manipulate the very fabric of space and time itself? If you think about it, this idea raises a lot of paradoxical questions. For example, what happens if we try to carry the portal through itself? Or what if we squeeze and put two interconnected portals on top of each other? Well, actually, there are no right answers to these questions. Since portals don't actually exist, we don't know how physics works in them. But we can try to imagine what would have happened and answer these questions from the logical point of view. So let's give it a try. Our first mind-boggling question is, what would happen if we took two interconnected portals, like in the Portal game, and passed one of them through the other? Starting with the hard one, huh? Alright. So we have two portals, the orange one and the blue one. Everything that gets into the orange portal flies out of the blue one, and vice versa. They're interconnected. If that's the case, then logically, if the blue portal passes through the orange portal, it has to go out of itself. But is it even possible? And what kind of chaos will something like this create? Theoretically, this is possible, but it will be very strange. Since the portals are interconnected, no matter how we turn and move them, the object going through them will always have the same position relative to them. In other words, if we kick the ball into the bottom of the blue portal, it will fly out from the bottom of the orange portal, and so on. Let's note where the top and bottom parts of our portals are so that we don't get too confused. So, what if we try to pass the top of the blue portal through the bottom of the orange one? Then the blue portal will come out of the bottom of itself. It's weird, but that's what should happen logically. And if we keep pushing it further, then the portal will crash into itself, and we won't be able to keep going. But if we try to pass the top of one portal through the top of the other, well, prepare for the complete nonsense. The blue portal will start to come out of itself closer to its top. This protruding part falls back into the orange portal. And the blue portal comes out of its protruding part again. In other words, now we have a portal going out of itself, going out of itself. It's quite difficult to understand and keep track of this. In general, if we want to fully pass the blue portal through the orange one, the very end of the blue portal has to finish coming out of itself, as it simultaneously disappears into the orange portal. But this is impossible unless the portal is infinitely thin. Otherwise, it'll get stuck, or squeezed, or something like that. So even though it's very weird and crazy, this is theoretically possible. The universe is full of surprises, huh? But let's relax our brains a little and move on to the simpler question. What happens if we open the portal in midair, for example, while falling, or underwater? In that case, would the water flow out of the portal to our room? Let's start with a midair one. Imagine that you're falling in the sky and create a portal right in front of you. It leads to your room, and the exit portal is horizontal. What happens then? In this case, you'll fall into the portal at your usual speed, and even after entering your room, you'll fly forward a little by inertia, but after the teleportation, the forces of gravity will immediately affect you. Because of this, you'll begin to fall to the floor as if in an arc. Eventually, you'll just fall face down on the floor. Not the best outcome, but still better than whatever option you had before. Now, to the underwater example. If you opened a portal under the water would definitely flow out on you. It would press down on the portal with all its weight and would flow until it filled all possible space. Or until the entire ocean would dry up. This would have a huge impact on the fish. If you opened a portal to the depths of the ocean, where the pressure is huge, and the water would start pouring into a place where the pressure and temperature are completely different, almost all the local marine life could say bye-bye. In other words, if one day we have portals, please don't do it. Now, get your brain in gear for another paradoxical question. What if portals could be stacked, with one leading to another, and so on, creating a chain of connected spaces? Would that be an infinite loop? A never-ending cycle of teleportation? Sounds like a sci-fi dream come true. But is it really that simple? Unfortunately, the answer is no. What happens in this case depends very much on the portals themselves and where they lead. For example, If one portal connected to a space with low gravity and another to a space with high gravity, imagine what that would do to your body. Actually, it's better not to imagine. But that's not all. If we do somehow create a chain of portals, it will lead to great instability or even collapse of these spaces. In short, the consequences will be unpredictable. However, all of these scenarios are just theoretical, as portals are a work of fiction. It's difficult to make a scientifically and logically accurate prediction of what would happen in these situations. The next question is, what if you could teleport into a moving object, like a car or a plane? Sounds scary already, doesn't it? Hold on tight, we're about to break the laws of physics. First, let's talk about momentum. When an object is moving, it's got a certain velocity, and you guessed it, momentum. This means, according to the law of conservation of momentum, the total momentum of a system stays the same unless an outside force comes into play. But what happens when we teleport a person into a moving car or plane? Well, that's a sudden change in the object's mass and therefore its momentum. This change in momentum can cause the car or plane to go haywire, potentially resulting in a crash or, at the very least, a seriously bumpy ride. And let's not forget about the shockwave that comes with suddenly materializing in a moving vehicle. It's safe to say things could get pretty nasty. So, again, if we ever get portals, please don't try this at home. And here comes the final question. Let's take one physics mystery and combine it with another. What if you could portal into and out of a black hole? Entering a black hole is incredibly dangerous, to say the least. It may end really badly even for an object traveling at the speed of light. The intense gravitational forces near a black hole can cause objects to be stretched and distorted into some crazy shapes. This is a process known as spaghettification, which is a really scientific term, by the way. And don't forget about the intense gravitational forces which cause the laws of physics as we know them to break down. In other words, your little portal experiment would have some catastrophic effects. In short, you would be spaghettified before you could even say, "Whoops, I shouldn't have done that." So, there you go, folks. The thought experiments about portals are a fun and imaginative way to explore the limits of our current understanding of physics and what could be possible in the future. While the scenarios we discussed are purely hypothetical and not based on any actual science, they still give us a glimpse of fantastical possibilities of the world with portals.